Let's return to our rig file. Let's start adding this linked effect to our rig. This is about using the controller that moves the wheel up and down and the corresponding locator that lifts the car body to create this linked effect. For example, if I select the controller and select the 0 group above the locator, and we move them together, we'll find this is the behavior we want. It's just that on top of this, we need to add the link details, like in our previous exercise, to give the wheels a certain amount of free movement even when the car body doesn't move. So let's start setting this up from the front left wheel. We need to note one thing here. I don't want to directly use the controller's translate Y to link with the locator. Why? Because this ground controller might need a group added to it in the future. If we want to constrain the controller to the ground, we would constrain this parent group and leave the controller itself for the animator, so the animator can make fine adjustments to it. Based on this consideration, what should we do? First, let's add a group to it. Let's rename it driven, then create a locator. We'll use this locator to represent this controller's translation. We'll call it ground pause. Pause is short for position. Then group it. This is our 0 group. Then snap it to the controller's position. Then use the controller to apply a point constraint to the locator. We know constraints are based on world position. So whether we move the controller's driven group or move the controller itself, or even if I move the controller's 0 group, it will all show the final value on the locator. Then we can use this locator's value to create the linkage with the locator that lifts the car body. But this locator itself already has an attribute connection, because there's a controller here. So let's add another group above it. Call this group connect. Then we'll use these two nodes to do the actual linkage setup. Select the position locator we just created. Then select the connect group, open the node editor, add them both. The method is exactly the same as our exercise. Let's do this quickly. I'll create a condition node. Call it suspension pivot up. Then let's duplicate one. This one is for down. Then connect the locator's translate Y to both condition nodes. Then let's look at the values. We'll still use positive 10 and negative 10. Keep it consistent with the shock controller's limits. For moving up, this is 10. And down is less than, which is negative 10. In the color if false situation, we want it to stay in place. This way, the car body won't move within this range. Then let's take the out color R here and connect it to our first condition node's color if false R. This way it checks the first condition node. If the condition isn't met, it checks the second condition node. Then let's create two add double linear nodes. To subtract that limit value. For up, we need to subtract 10. For down, we need to add 10. Then connect them. This way, we connect the final result to the connect group's translate Y. Let's take a look. We'll see the car body will move with the wheel. But within this range, it won't move the car body. But we'll see here when I move the wheel up, it intersects very quickly. What does this mean? It means the locator isn't moving up enough. How can we modify this? We can add a multiplier. Although it's driven by the result of the distance subtraction, we can multiply it by a number greater than 1 to make its movement distance relatively larger. Let's create a mult double linear node. Connect the value from the add double linear node. Let's set it to 1.1 for now. We'll need to adjust this value later. Then connect this result to color if true R. Okay, let's check now. There's still intersection. Let's increase it to 1.2 or 1.25. That might be better. Let's look at it now. The intersection is not as obvious. It's the same for moving down. Downwards, we feel the car body isn't lowering enough. The gap here is a bit too big. So let's create a more double linear node. Then let's see. If it's 1, it's the current effect. Let's set it to 1.5. Feels a bit better. Let's look at this effect. Okay, the effect for the front left wheel is done. Now, let's place the corresponding locator we just created under the same hierarchy. That is under our car body's back controller. Put it as its child. This way, let's check. When we move the controller, it has this behavior. But let's check here. When we move it, our controller that controls the car body's up-down movement isn't moving along with it. It looks really bad. What do? We can take this shock controller and also put it under the controller that moves the wheel up and down as its child. Let's look at it this way. Looks much better. This way, the front left wheel setup is complete. Let's use the same method to quickly do the remaining wheels. We'll start with the front right wheel. Create a group same as before. Duplicate this position extracting locator. This is the right side locator. When duplicating, don't forget to delete the duplicated constraint node, because this node is useless now. Then snap the 0 group over. Next, use the controller to apply a point constraint to the locator. Then the locator and the connect group above the locator that lifts the car body. We need to create a linked effect with them. Clear the nodes we just created from the node editor. Maximize the window. Then let's see. This is our node connection for the front left wheel. Let's use the same method to connect the front right wheel. The settings for the front right wheel are all the same, so let's duplicate all the nodes and rename them. The benefit of duplicating is that all the values will be preserved. We don't need to set them all over again. If we create new nodes, we'd have to look up the values we set before and set them all again. This way, all the nodes are set. And here, let's connect the locator's translate Y. Connect it to the add double linear node's input 1, and the other add double linear node also input 1. Then connect the add double linear node to the mod double linear node. Then also connect translate Y to the condition node's first term. Finally, connect the condition node to the connect group's translate Y. This way, let's check the right side. The right side has same linked effect. And don't forget to parent the shock controller as its child. Next, same operation. Let's do the two rear wheels. Here, because when I was creating the nodes, they were all being automatically added to the node editor. It looks very messy, so let's temporarily lock this. This way, all the nodes I duplicate won't be automatically added to the node editor. Let's continue setting up the rig. Snap it over. Then use the controller to apply a point constraint to the locator. Then create a connect group above this shock locator. Then same operation, select these two nodes, add them to the node editor. Let's turn auto add nodes back on, because now we need to duplicate these nodes and these nodes, we want them to be automatically added to the node editor. Don't forget to rename. After they're all renamed, it's the same operation. Take the translate y, connect it to the add double linear node's input 1. Add double linear node connects to the mod double linear node. And then take translate y and connect it to the condition node's first term. Finally, connect its result to the connect group's translate y. This way, let's look at the back. The effect looks okay. The rear wheel structure is a bit different from the front wheel. So for a better effect, we can fine-tune the two multipliers we just used. That one was 1.25. For up, maybe I'll change it to 1.5. 1.5 might be a bit too high. 1.3 looks a bit better. When moving down, this was originally 1.5. Let's try 1.7. The effect seems relatively better. Of course, we can also change this limit value based on our needs. Our current limit is plus 10 to negative 10. Sometimes we might feel this range is too large. We can also modify it based on the effect we want. Okay, the rear left wheel is done. Don't forget to put the shock controller under the wheel's up-down controller as its child. And here, let's lock the node editor again. And then do the rear right wheel setup. Use the controller to apply a point constraint to the locator. Find the locator that controls the body lift. Add a group. Then add these two nodes to the node editor. Duplicate the nodes from the rear left wheel. These are the nodes we need for the rear right wheel setup. Rename them first. Then the same connection order. Finally, connect to the connect group. Then let's look at the right side. The right side has the same effect. Finally, let's parent the right shock controller as its child. And last, don't forget to clear the node editor and close it. This way, the linked effect between the wheel's up-down controller and the car body's lift is now complete.